inviting me again to talk on second generation of ethanol. In the previous presentations, you're seeing there's great mention and great hope for second generation ethanol. Basically, what is second generation ethanol? It's ethanol produced from lignocellulosic raw material. And that is bagasse, that is straw, that is trash from agriculture, agricultural waste, municipal waste. So it's a big field, and I'm just going to quickly go through the aspects, possibilities, and the challenges of producing second generation of ethanol. Okay, first thing, as we've seen in the previous presentations as well, there is a growing demand for renewable and sustainable fuels. And I think now we're all aware why the CO2 is accumulating in the atmosphere and it's affecting the world as a whole, and there is a bigger demand and a requirement to find renewable and sustainable fuel. Okay, cellulosic biofuels have this potential. As in the previous presentation, we have the possibility to reduce CO2 and recover and use sustainable renewable fuels. So the possibility is there, and cellulose is a big contender to meet that demand. There are now in the world pilot plants have been installed. You can see in many countries throughout the world, in India as well, now a big push to put second generation bioethanol. So the whole world is involved in looking for this renewable second generation ethanol. There are many processes and combinations, and mainly it's a combination in order to produce this second generation bioethanol. We need a combination of heat, enzymes, chemicals to break down the cellulose. Once we break down the cellulose, we then perfectly know how to get to ethanol. Once we get sugar, everyone knows how to get it to ethanol. So really, the big emphasis is in the breakdown, the reduction of cellulose into fermentable sugars. If we look at the USA, which is probably the biggest consumer of gasoline, you see that there is already, without increasing agriculture, without increasing any production, there is enough cellulose to produce 300 billion litres of bioethanol per year, which is 60% of the annual consumption in the USA. So the cellulose is there, the cellulose is there. The challenge we've got, which is we're all responsible, is to establish this cellulosic biofuel, second generation ethanol industry to meet these demands. We've got to overcome competition from fossil fuels, conventional biofuels. We need government policies to assist us. We need regulations in blending and other policies to help this industry of second generation ethanol be successful. So let's go back a bit. Let's see what we've got, what the challenge is really. So we can see ethanol has been being produced for more than 100 years. And these are typical, you see there a list of typical raw materials. Obviously sugarcane is in there, sugarcane and molasses, which are the big producers of ethanol at the moment. And cellulose has the potential to produce basically we can now produce 20 liters per 100 kilos. The objective to compete against these other raw materials, we need to get up to the 30s and 35 liters per 100 kilos. Okay, again, these we're producing fuel. I call these energy crops. We can group these together. Obviously, sugarcane is a big producer of alcohol and ethanol, and there are various products from sugarcane. C molasses. We talked about B molasses. We talked about cane juice. So all these are available from sugarcane. So sugarcane obviously is a big player in producing ethanol. There are other sugar crops, sweet sorghum we spoke of, sugar beet, fruits, all these can produce ethanol. Then we go into the second group, starch-based products, energy crops. So there we've got cereals, corn in the USA, cassava, Thailand, potatoes. So any food crop, any starch-based food plant can produce ethanol. And then in the last group, this is where we're going into second generation, and we're looking for cellulose biomass. Cellulose biomass, as I said before, there is a huge amount. Cane bagasse, straw, corn stover, agricultural waste, municipal waste, paper, cardboard, all this is cellulose. So any fuel ethanol process, even with conventional materials, even with the new second generation, we go through a series of steps. Okay, the first thing, pre-treatment of the raw material. Basically, from the raw material, what we want to get is a fermentable sugar. So, depending, obviously, with sugarcane, the fermentable sugar is already present, so it's relatively simple. But cellulose, obviously, is a lot more complicated. And then once we've got the sugar, the next three steps everybody knows: fermentation. We convert that sugar into ethanol. The ethanol is of a low concentration, so we need distillation and dehydration to remove the water content to get the ethanol, which is then used as a fuel. So we'll see, as I mentioned before, sugar is the easiest. We all know the sugar processes to produce ethanol. Whether it's from molasses or juice, obviously it's going through the sugar factory, the molasses is produced or the sugarcane juice is produced. We can go directly, once we get the correct concentrations, we can go directly to fermentation, distillation, etc., etc. So this is well known and been very successful for many years. Starch-based compounds. So now we're looking at corn and cereals, cassava. We have one step more. Because we don't have the sugar, fermentable sugar in the raw material. So we need, in the preparation section, we need to saccharify the starch to break down the starch chains into fermentable sugars. So you can see there's jet cooking, there's cooking, pre-liquefaction, saccharification. All this is to get, is a hydrolysis process to get fermentable sugar, and off we go. Once we get the fermentable sugar, we can go for fermentation, distillation, etc. So you can see that any distillery with any feedstock will have these sections. You will have a basic process, preparation of your feedstock, fermentation, distillation. And this is surrounded by a series of utilities and storage areas to make the whole thing operative. Okay, so we apply this to second generation bioethanol. again, looking at the raw materials, basically we have to look at the cost of production. We have to look at the cost. Basically, we take two things into consideration: the cost of the raw material and the cost of production. The sum of the two will give us the cost of the final product. So you can see traditional raw materials, molasses and sugarcane, fairly low, medium cost of raw material. Obviously, what's happening as molasses gets scarcer and scarcer, the cost of molasses will go up. Corn, wheat and barley, the starch, high cost, but the yields are good, so they can be competitive. Let's look now at new energy crops. So, being used now in the US extensively is grain sorghum. It's similar to the cereals. High cost but high yield. Sweet sorghum we mentioned before. Similar to sugarcane, medium cost, but the yields are fairly low. Cellulose. Cellulose is readily available and has a very low cost. Nor it's waste, as the presentations mentioned before. Cellulose is normally thrown away. So the cost of the raw material is very low. However, as we will see, the process cost is variable and is being investigated. So let's look at cellulose. We said lignocellulose materials. Okay, so there we can see sugarcane bagasse, which is the one we're most interested in the sugar industry. So basically there are three groups, three components. Cellulose 48%, hemicellulose 24%, and lignin, which was also mentioned previously, 25%. So these are three main components. To the next one. So what does this look like in the bagasse? Basically, these three components are all blended together in strands. The strands are impermeable, they don't dissolve in water, they're not penetrable by water, so that makes it very difficult to treat. Basically, the cellulose you'll see on the diagram there, the long thin strands, and the hemicellulose is mixed in with there, and the lignin acts as a cement, which cements all this cellulose and hemicellulose together, forming the strand. Right? So the task is to break open this strand and get at the cellulose and hemicellulose. Cellulose. So let's look at the three components. Cellulose basically is made up of glucose C6 sugars in long polymer chains. Again, impermeable in general. It's a crystalline, impermeable structure, difficult to access by water and other components. So those are the strands in the bagasse, in the lignocellulose. Hemicellulose, again, similar to the cellulose, but they're made up of C5 sugars, pentose, long chains of C5. Some C sugars are there, but mainly it's C5, so pentose sugars in long strands. And then we have the lignin, which is the cement, which cements all this cellulose and hemicellulose together, and is really preventing access from the outside to the cellulose and hemicellulose. It's a complex, lignin is a complex molecule. As you see, there's phenylpropane chains, which is insoluble in water and very difficult to break down. Okay. So going back to the process again, remember we have pre-treatment, and then we need to get to fermentation. After that we know what to do. Okay? So the pre-treatment basically is in two steps. The first step is to try and break down these strands, these chains, or to break down the strands so that we can have access to the cellulose and hemicellulose. So methods used, you can see a whole bunch of methods to break up the strands. Mechanical milling, okay, so that is milling to get fine particles, again to get access to the strands. Steam explosion, this is using steam, high temperature, high pressure to explode the cells and the strands. Using organic solvents, chemical attacks with strong acids, strong alkalis, cryogenic freezing, so that's freezing and then to expand the cells. Investigations have been done into microwave, ultrasonic, radiation, strong alkalis, you name it, it's been looked at. So once we get access to the cellulose and the hemicellulose, we need to break the chains, we need to break the chemical chains, and that's a process of hydrolysis. Basically, hydrolysis can be done in two methods, two ways. It's a chemical hydrolysis using acids and alkalis, or we can use enzymatic method, just using enzymes to break down the chains. Once we've broken down the chains, we basically end up with two types of sugars: C6 glucose, C5 pentose. Okay. There are byproducts. Byproducts, obviously, lignin fuel. Lignin is the component which can be burned in the boiler, and it's can be used as fuel. And we saw before it can be used as a component for producing chemicals. Hydrogen is produced in some fermentations of C5 molecules. Liquid CO2, obviously, from glucose and sucrose fermentations. Biogas from waste treatment. So many byproducts have to be looked into. Okay, I'm going to quickly go through pre-treatment. Okay, we said in two steps: rupture of the lignocellulose structure and then hydrolysis. Okay, I think I mentioned before most of those. We have to objectives during this stage: maximize the area for hydrolysis, minimize the loss of sugars, because doing steam explosion, strong acid attack, we also have the chance of damaging the sugar and losing the sugar. So we have to be careful on the amount of corrosion we perform. Minimize the amount of fermentation inhibitors. That's another offshoot. When we attack chemically or mechanically, we produce some inhibitors which then reduce the fermentation afterwards. So and obviously cost and energy is a consideration to be taken into account. Okay, again here I'm listing the methods used in this first step, this pre-treatment, which is where most of the investigation is being done. I've gone through most of these previously, so we'll go on to the next slide. This is basically what we're trying to do. Right? You see on the left, this is the cellulose, the lignocellulose before degradation, and basically what we're trying to get is what's on the right. It's to break the strands to get access to the cellulose and to get access to the hemicellulose. Hydrolysis, I mentioned previously as well, chemical. Yeah, okay. Let me just quickly go through. There are the pros and cons of hydrolysis. Fermentation, basically we have to consider two types of fermentation, the C6, which we all know, and the C5. Okay, the C5, this fermentation, C5 fermentations, obviously not done by yeast. It's done with bacteria. There are different types of bacteria, and we have to look into whether we do it at the same time as the C6 or whether we do it separately. Okay, lignin we can recover. This is an example of one process. The blocks, what we mentioned previously, and the blocks can be changed around. So the lignin can be removed at the beginning, can be removed at the end, etc., etc. So we're close to the end here. So processes today, we can reach up to 240 litres of alcohol per tonne of cellulose and converting the cellulose. But we really need to look into converting the hemicellulose as well into alcohol, into ethanol, in order to be able to reach our target of 350 litres of cellulose, 350 litres of ethanol per tonne of cellulose. And this, today, most people are looking into enzyme to achieve this figure. So, second generation ethanol is still work in progress. We need to look at ways to be more efficient, to be more cost effective, and consume less energy. Thank you very much. Thank you. Thank you very much.
So far we heard the theoretical part, the conceptual part of how the ethanol blending or ethanol generation happens. The moot question, sir, is India we produce about 300 million tons of sugar cane, and we require about 25 to 26 million tons of sugar to eat. So what is left can only go for ethanol. So to emulate or to think what Brazil does or elsewhere they do has less relevance because we have a population to feed sugar also. Now, the whole object of presenting that is, we have simpler solution and we look at it. Simpler solution is what is doable today. We are not talking about the future because we are all the people who have been operating people in the factory, so we look very myopic way. So these are all the theoretical things. Ethanol production, everybody knows. I don't have to go through this. See, sugar industry in India is cyclic, and therefore the ethanol blending program is affected by the cyclicality. There is a years of high molasses availability, there are years of low molasses availability. Grain ethanol is not cyclic. Then from sugarcane we get about 49,000 liters per hectare, whereas we get 24,000 three crops. So that's almost 3 times from the grain. The sugar factories typically has got all the resources to have agribusiness. Now we have become from sugar factory to sugar complex. From sugar complex, how to graduate into agribusiness. One of the areas is combined grain ethanol in the distillery as a dual feed distillery. You have molasses option, you have a grain option. It will not cost more than 12 to 15 crores to add a grain facility. Grain has no effluent, therefore no pollution boards or that problems of that. Grain has a byproduct called DDGS, which can be sold at 30 rupees a kg. So these are the resources we have. We have a manpower, we have a land, we have power and fuel, we have off-season campaign, off-season period, huge facilities of the management systems of purchase and sale and etc. maize production in India is growing at 5.5%. Then we have 219 lakh metric tons of grain, maize particularly. So we can do intercropping of sugarcane with grain, which is about 7 to 8 tons, and in some parts of Bihar there is a grain yields are as high as 10 tons to 11 tons in Katihar and Motihari, in Pune and other places. And this is the availability of maize all over the country. Now, when we talk about molasses, whether B or C or cane juice or anything, mainly two states produce sugarcane or sugarcane products like molasses. To transport the whole thing into the whole country becomes prohibitively costly. So grain can be, maize is grown in a dry areas also. So there is an availability of grain as a raw material at various places. The transportation cost is less. So in a state like Northeast, which is Jammu Kashmir, the UP cannot supply to everybody, like Maharashtra cannot supply the whole of southern India. So grain can be a well spread and can be integrated with sugarcane. Current scenario, if you take C molasses, there is a shortage of serious shortage of molasses ethanol, even for 10% blending. If you see this additional, whatever we require, there is a 8.7 million liters of molasses shortage, 10% blending. With all the talk, we have only achieved 5.17 or 5.5% ethanol blending. And for 20% we have a 4.1 billion liters of shortage. And we have about 360 molasses distilleries. We have about 85 grain distilleries, 85. And dual feed distilleries are only 25. There is a huge scope to convert or add on the maize or grain, whether it's a broken rice or it's a maize or it's a millets. All this can be added into the distillery which we have. And business always operates on optionality. We should have an option to do A or B depending upon the economics. So this grain or dual feed distillery gives that scope. This is the present consumption of grain. Practically, it doesn't make any difference if grain is diverted to ethanol, because the poultry feed can be substituted with the DDGS, which is also very high protein content. Only thing is the cattle feed level, cattle are not supposed to eat the proteins. So cattle feed can be substituted with other forage, and direct consumption will not get affected. Beverages won't get affected. So grain adding to the ethanol program is really a doable thing. The future scenario will be like this: 1.5 to 1.92 billion liters from molasses, 3.2, much more than molasses, is from maize or rice or any other grains, and ethanol from the broken rice is 1.35. Then you have other raw materials is about 0.13, and what is required is 6.6 billion for the ethanol blending at 20%. So this is the scheme of things that may work out. So looking into all these things, the policy makers like Ramakrishna, they thought about it. They included the grain based ethanol price has increased recently by Government of India, or the oil marketing companies, by 2.73 rupees more per liter. It is now from 47.13, it has gone to 50 point something. So there is a big debate, talk and encouragement for the grain based ethanol, because that's the only way we can achieve the ethanol blending program. So as I told, if North Indian states have to be served, that can be only served. We have a well spread of ethanol production from all over the country, instead of concentrating only on sugar industry. Sugar is definitely a major one, but does not suffice the ethanol blending program. So we have to view the things, problem into two separate things. Is it ethanol blending program we are talking, or are we talking about doing something in the sugar industry? There are two separate things. Ethanol blending program definitely requires support from the grains. It cannot be only from molasses. The obvious reason is we cannot produce 600 million tons of sugarcane in the near future. I won't say it will not happen. So if 300 million tons of sugarcane is produced, obviously substantially goes for the making sugar. And what is left over only can go. We can say B heavy, we can say juice. After all, at the end of the day, sugarcane that matters. And that sugarcane cannot be doubled. So therefore, there is a need for a dual-based distillery. If you want to run the program of ethanol blending. So this is precisely the point that I want to make. The grain is a in thing. People produce it. Farmers are great benefited. The MSP of grain is 17 rupees a kg, 17,000 rupees a ton. And at the time when it is produced, for distress sale, it is sold at 8,000 rupees to 7,000 rupees. Obviously, the farmers will get greatly benefited if demand is made. And this is for the good of the country, and the new futuristic things will keep on happening. I am not saying they are not going to happen, but what can be done today? What happens in the years of low sugarcane production, like what happened in Maharashtra this year? Nobody would be able to really 10,000 rupees a ton molasses. Doesn't make a sense to make ethanol. It is 41 rupees is the cost of raw material at the yield which we are getting, and another 10 rupees you add, 51 rupees you have to sell at 43 rupees. Nobody would do that. It's a be heavy you divert or do anything. It's a sugarcane and sugarcane juice and sugar content that matters. So this is what is to have a different look, which is doable, which is not something the rocket science. And the most important thing to think is that are we able to run this EBP program? Then we have to think about these things. If we are only, do only in the surplus years, that's a different thing. The grain ethanol price is fixed at higher, and it is possible to increase further. Then definitely the industry wanted that it should be 55 rupees. 50 has been agreed per liter. Obviously things will go further. This is precisely what I want to say. The process technology are all economic slides. There is nothing new I can show that. Different types, and there is no effluent, there is no environment issues, there is no CPCB, there is no NGT, there is no state pollution boards, and there is nothing you should worry. Make ethanol from grain, and which is not a new thing, but to be attached. And here are all the economics of producing grain-based ethanol. And the yield of ethanol from a grain maize is 410 liters, and from broken rice is 460 liters, compared to 230 to 240 liters per ton of molasses. So these are the strengths and weaknesses we analyzed. And then in US, most of the ethanol is produced from the grain only. We are not talking anything new. This is the model which we can look at it. We can use these models to combine the industrial sector and agriculture sector. And conclusions are obviously before you, sir. So I think I tried to cover it in short time for a different reason. The reason is we have one presentation which was skipped because the main presenter hasn't come. In his place, his company executive has come. He made a request that he should be allowed to speak. Sir, only one caution, exactly 5 minutes. Because next session man will kill me if I overstep this time. Thank you very much.
I'll talk to 5 minutes. I'll not waste my time. Thanks, Lisa and Chair, for inviting Praj Industries and GMT Praj Industries. And whatever the things has been explained right now, from the analysis, the strategy, and up to chemical analysis of different raw material. Now we have done that study from 2008 till date, and we come up with different technological view to see that how this technology will be much more viable in Indian context. So we are now in the practical commercial phase, not in the R&D phase. R&D is going its own way, but we have signed 4 agreements with the oil marketing companies to set up 100 kiloliters per day from different raw material to ethanol plants. And that's where we used to say that Praj is why we are thinking ahead of the international market also, because we done that right work from the base. Not only to see that bagasse can be the raw material, rice stock and the raw material, but practicality and application into the commercial market to make it more viable is the base of Praj industry. I respect all the technology providers and engineering companies, but we have now, as an EPCM, also we come up with the IOC project. And that's where the engineering integration lies. And we respect to all the developments happening in the world. So in lignosulfonate, we are coming up, as YBC already mentioned, we are coming with the aviation fuel now. So we are using molasses to produce the aviation drop-in fuel. So these technologies we are building not only for the India but also for the nation. So that is what we have the confidence to push ourselves here. As my honorable chairman is not present today, he is going to be present tomorrow. But it's my own responsibility, and as a national, we believe that we have to do work for the farmers. Everybody is talking on technology, business prospect, but very less people are thinking about the farmers' prosperity. So if we keep farmers' prosperity as a central model, by putting our entire efforts and going back into the field to grow the farmers' income, then all technologies are going to survive. Otherwise, no technology is going to survive in Indian prosperity. So I strong believe that what Sir Dr. Saab has told, circular bioeconomy with farmers' prosperity is the key. If you are not going to give back farmer a doubling income or using its organic carbon for the production of ethanol and vacating the soil, no, it's not going to work. So we have to give back something to the farmers to develop its own crops as energy crop or models or geoforest models. Based on that, all technologies are going to play a very crucial role in Indian economy. So as a CGR of 8.38 for the gasoline, we have to double it the production rate of the second generation of advanced biofuel for Indian continent minimum. As a national, yes, European customers are there with us. We are signing different agreements. We are going ahead with a very strong pace for the Indian scenario as well as national and global. But my strong thrust is that keeping a farmer as a backbone of the economy, we have to see that how he is going to prosper. And such technologies we are developing, such technologies are going to implement into the India, and that's what commercial projects we are doing. Challenges of straw burning, challenges of power, conversion of power for bagasse is going to be a big challenge. So that entire residue we are converting for something value-adding products. And there practically, if we see that all carbon has to go back, but we have to capture more carbon also to make it more environment friendly for our next generation. That's what the theme has come. And based on that, with the support of Government of India, with Ministry of Petroleum and Natural Gas, we come up with certain projects. Now, with 2021 August, we are going to commission our first commercial plant in Panipat. Second will be in Odisha by 2021 December, 2022 third project, and 23 again and fourth project. Alongside, we are doing with the European government several projects. With that, thanks for permitting me to take a time, and thanks all to listen it very carefully. Thank you very much.
We don't have time for the questions, but one question for Mr. Ramakrishna, because from the viewpoint of the sugar industry, it is excellent that the OMCs have given the differential prices and one of the best prices for the ethanol. But they are announcing it only for the 1 year. In fact, many of our sugar mills who are not having distilleries, they want to go for setting up distillery plants with facility to convert juice to ethanol, and for juice to ethanol, again the downstream implementation system can change. So depending on this, they have to invest. So if you can announce a policy for say 5 years, long-term policy, then probably we can definitely plan for
putting up the Destil units, and in long term we can definitely supply ethanol to your oil mill. So,
in addition to that, banks and financial institutions are asking for some clarity from all period of loan. 5 years, 7 years, like that. The clarity of price of the ethanol.
we all must realize that the price for molasses-based ethanol is not finalized by the Ministry of Petroleum or by the oil marketing companies. It is fixed by the Food Ministry. Because the price for ethanol is always linked with the price of the sugar. So it is a well-oiled mechanism that has been put in place with the sugar industry also sitting on that kind of a committee, and where the price has been fixed. Now, supposing the price is fixed, and if your sugarcane production comes now, and if you are not in a position to supply the kind of ethanol that is really required because you have to meet the requirement of sugar, then what will happen to the ethanol blending program? So keeping in mind the kind of cyclic nature of the sugar industry itself, the pricing mechanism that has been fixed at this point of time is not purely by the Ministry of Petroleum. It's the Ministry of Agriculture and Food which really determines that, and I don't think for in the near future there is not going to be any kind of a change in this. And as far as the bankers are concerned, there was a time when bankers were not willing to accept, basically because we didn't even had this kind of government administered pricing mechanism for this. So the program, I mentioned that, from 1.4 to it has gone to 6%, basically because of the administered pricing. In the previous regime, there was no administered pricing, and the oil marketing companies were offering something like 28, 30, 31, 32 rupees for every liter of ethanol. Obviously, the sugar factories were not able to supply. So you see that there is some amount of stability that has come into the market, which is something that has to be, as far as the financial institutions, bankers are concerned, they need to be educated on this. And I think an effort has to be made, and I'm pretty sure OMCs and ISMA together have been trying to educate the bankers on the changed circumstances. And I'm pretty sure the new financial institution that I have been talking about, where government is really thinking in terms of putting it together as early as possible, then the rate of interest will further come down, and it is not just looking at making easy investment, but someone who understands the bioenergy space and make sure that there is, in addition to the financing, there's a lot of hand-holding that's going to be done to the bioenergy industry. It's not just the sugar industry, any bioenergy industry for that matter. And this is something, probably is going to happen in the next, I would say, any time between 6 months to 2 years.
No, that comes to an end of this session. Just a few closing remarks. We had excellent presentations from many learned speakers, Dr. Yadav and Mr. Ramakrishna, and Mr. Praj, and then Roma. Mainly, the discussion as it should be and it is on the futuristic way, what we can do and what we can think of doing it, caring for the future technologies. And I went with a very critical thing, ugly thing, that what can we do? If ethanol blending program has to sustain, blending program has to sustain.
May I request Professor G.S.C. Yadav to come on the dais and receive the memento from our trustee, Dr. Indrajit Moite. May I request Mr. Ramakrishna to